Okay. Now with that, the main claim is going to be super easy. Let's do a proof. So now I'm proving the claim. So the proof goes like this. Remember, it's a biconditional, so we have to do both directions. We're going to do left to right first. It's going to be harder. You know, let's get the hard work out of the way. So proof. Once again, it's a direct proof. So we always start with the whole arbitrary but particular thing, because it's how direct proofs work. Assume A and B are any integers. If it works for any of them, it works for all of them. So let A and B be arbitrary but particular positive integers. All right. Now assume A, in fact, assume A divides B and B divides A. So once again, we're just letting A and B be arbitrary element domain, and then we're going to assume the hypothesis and prove the conclusion, since we're dealing with this first direction, left to right first. So assume A divides B and B divides A. Then, here's the beauty of the lemma, all right? By the above lemma, since A divides B, A is less than or equal to B. Further, since B divides A, B is less than or equal to A. Also by the lemma. Therefore, A is less than or equal to B, is less than or equal to A, so A equals B. This is the beauty of a lemma, right? Just this little lemma right here made this proof instant, basically. So lemmas should not be underappreciated in math. They're awesome. Now let's put it the other way around. Lemmas are like, who's that guy that was Gaston's right-hand man in Beauty and the Beast? LeFou? Sound like that? Lemmas are like LeFou, right? Not to be underappreciated. I mean, I mean, this is the main thing, right? But lemmas, they help out a lot. But where are we gonna stop doing that LeFou is the point. Anyway, here we go. Let's go the opposite direction. Now let's assume. So now let A and B. Actually, we don't really need that. So now assume that A equals B. Since we're using the main as let A and B be arbitrary integers, right? We're just using a different assumption. Instead of assuming the left side, we're going to assume the right side. So we have to write the arbitrary in particular again. Assume A equals B. Then A equals B, which equals B times 1. So, since 1 is an integer, B divides A by definition of divides. Right? Further, B equals A, which equals A times 1. So since 1 is an element of Z, A divides B by definition of divides. Thus, A divides B and B divides A as desired. Done. So, A divides B and B divides A is equivalent to saying A equals B. If this happens, this happens. If this happens, this happens. They're basically equivalent things. Any questions? Good. I hope this makes sense. And by the way, this is just like when we were talking about logical equivalencies. When I talked about like why would you care about writing something in a different way? That is because sometimes you write it in a different way, even though it's equivalent, it might be easier to think about that new perspective. And same thing here, right? The reason this might be a useful lemma, or the reason this might be a useful theorem, is because sometimes it might be easier to prove that A divides B and B divides A than to prove that A equals B. That's the actual thing that comes up. It might be easier to show this. The thing about A equals B in this perspective might actually help you prove things. Also, it's kind of cool. Not everything has to be useful. It can just be nice and fun and give you joy in the inside. Isn't the real point anyway?